Good afternoon, everyone. Welcome to this episode of EfD seminar series. I'm representing Women in EfD's Women in Environmental Economics for Development program. And we have two distinguished speakers here. So I'd like to say a few words about the program first. So WINED is a program built around building a pipeline of women economists and enhancing the capacity of women in the global south to take on research leaderships in environmental economics for poverty alleviation. And this is exactly where we have invited two young and upcoming, very potential, strong researchers in environmental economics. So the first speaker is Amaka Nnaji, who's a postdoctoral fellow at Evans School of Public Policy and Governance at the University of Washington. And she's also a research associate with EfD Nigeria. Our second speaker is Raavi Aggarwal, a visiting assistant professor at the Center for Research on the Economics of Climate, Food, Energy, and Environmental Economics at the Indian Statistical Institute. And she's also a research associate with EFD India. So the way we have organized this seminar is in two sessions. The first speaker is Amaka. She'll be speaking for about 20 minutes, followed up by a discussion on her presentation. And then once we conclude Amaka's session, then we'll move to Raavi's presentation, and the rest of the half hour will be spent on Raavi's presentation and discussion of Raavi's presentation. Over to you, Amaka.
Can you hear me now?
Yes.
Perfect. So thank you very much, Mintewab. Can you see my slides though? Can you see my slides? Sorry.
Yes, we can see them now.
Yes, we can. Yeah.
Perfect. Thank you very much, Mintewab. And I want to thank everyone that is attending this webinar. I'm very happy for the opportunity to share my research with the EFD network. So my presentation today is titled Risk Perception, Farmer-Herder Conflicts, and Production Decisions, Evidence from Nigeria. So this is one of the papers from the bigger body of work I do for my thesis that sort of examines the direct and indirect impacts of farmer-herder conflicts on rural livelihoods. It was co-authored by my supervisory team, inclusive of Nazma Ratna, Alan Rennick, and Wanglin Ma. So this presentation will take the following outline. I'll have a brief discussion about the motivation for the study and and the objective of the study. I'll talk about the data and methods used, discuss the findings, and finally conclude. So moving on to the background. Of late, rising global temperatures and in the resulting drought and desertification has increased the likelihood of farmer-herder conflicts. And of course, this is as a result of greater competition for scarce land resources by nomadic herders and sedentary farmers on the other hand. Of course, these conflicts arise as a result of increasing competition or increasing climate change stressors, among which would be flooding, rainfall anomalies, drought and desertification. So in Nigeria, and really in most of Western Africa and some other countries of Sub-Saharan Africa that have the same problem, nomadic herders typically or traditionally graze their animals in the northern region of the country. So in the Sudan and Sahel Savannah, during the rainy season when there's ample pasture. But then in the dry season, they tend to migrate southwards towards the mangrove forest in search of pasture for their animals. Traditionally, the relationship between herders and sedentary farmers has been symbiotic. So in the off-season, farmers invite herders into their cropland to graze the animals on crop residue. And in the process, they fertilize, so the droppings from, cattle don't fertilize the cropland for, farmers.
Stephen Graham.
So this has been, it has been a single.
I'm working on it. Okay. We're paying him a lot for a small enrollment. Yeah. Yeah.
So it has been a symbiotic relationship, traditionally. But then of recent, I think in the last decade or so, with increasing onset of, drought and desertification, nomadic herders, tend to migrate southwards in search of pasture for the animals. And also with increasing terrorist insurgency from the northeast, they tend to migrate, further south, even during the planting season in search of pasture for the animals. So, of course, this increases, competition over scarce land resources by both herders, nomadic herders on the one hand, and sedentary farmers on the other hand. Typically, these conflicts arise when nomadic herders, in their bid to look for or to graze their animals, sometimes graze the animals on farmers' cropland. Of course, this leads to crop damage, loss of yield, and income for farmers. Farmers retaliate by either, maiming these animals or chasing herders from their communities. Herders fight back, and the vicious circle of farmer-herder conflict ensues. It has risen significantly in the last couple of years, in the last decade or so, and it results in dire consequences for both parties. So it leads to loss of lives, loss of property, as well as, decreased food security of households. So another paper in my thesis investigates this relationship and finds that increased incidence and severity of these conflicts tend to reduce rural households' food security. So, doing a review of the literature, we find that armed conflict, has been found to negatively affect agricultural outcomes. But then we see that in most of these studies on armed violence, they tend to consider only exposure to armed conflict or terrorism, terrorist insurgency, rather than farmer-herder conflict. So there's a shortage of studies that empirically investigate the indirect consequences of these types of resource use conflict on agricultural outcome. Basically, little or nothing is known about the wider impact of this kind of conflict on households that are not directly involved in this conflict. And determining how these how rural households perceive the risk of conflict influence their production decision, but it will also clearly show the the other channels through which this ongoing conflict, farmer-herder conflict, can influence agricultural production. So, to address this obvious gap in the literature, in this study, we try to examine how the perceived risk of farmer-herder conflict influences rural households, rural households' production decisions. So, to achieve this objective, we develop a theoretical model of conflict, and we do this by extending the classical farm household model with the introduction of an exogenous shock in the form of the risk perception of conflict. So this theoretical model assumes that rural households' risk perception of farm-herder conflict would affect their production through its influence on their investment decisions. Based on this theoretical model we derived the following hypotheses. That the risk perception of farmer-herder conflict would not influence households' investment in productive inputs like fertilizers, and will not influence the area of land they're renting for cultivation, as well as their time allocation for farm work. So, to test this hypothesis we derive, we use primary cross-sectional and household level data from rural Nigeria. So, a multi-state sampling technique was used to select households to be included in a survey. In the first stage, 2 geopolitical zones, 1 state in each geopolitical zone, and 5 local government areas in each state were purposely selected on the basis of a prior occurrence of farmer-herder conflicts in these areas. And in the second stage, 2 towns in each local government area, 2 villages in each town, and 10 households in each village were randomly selected. An extra household was interviewed in one of the villages, making a total of 401 households for our sample. So this fieldwork was conducted between July and August 2019. And before we did main fieldwork, we conducted a pilot study in the survey of 25 houses in the survey area to improve validity and reliability of the instruments we use. Also to make sure we're collecting the right data. So moving on to the construction of our key variables. So the main independent variable for this study is the risk perception of farmer-herder conflict. And we construct an index that captures the risk perception of farmer-herder conflict by modifying a risk ranking method that was used in Doss, McPeak, and Barrett 2008. So how we do this is that we present our respondents, which is rural households, with a list of possible concerns as a result of conflict that occurred prior to that particular agricultural season. They were asked to choose the concerns they were most worried about and then rank them from greatest to least worried. So with that, using equation 1 here, we sort of generate a risk assessment index for each concern. And afterwards, we come up with an intensity measure of households' risk perception of farmer-herder conflict by summing up the risk assessment indices of all the risk for each household using equation 2. For further analysis and also following the expected utility theory of risk aversion, we divide households into 3 risk groups by splitting their risk perception into totals, right? And this is to capture the different stages of risk behavior: risk-taking, risk-neutral, risk-averse. Just to be said, just so clear, this is a relative measure of risk aversion as against an absolute measure. So moving on to our key outcome variables, we focus on 4 production decision variables in this study, and they are: 1, the decision to use fertilizer. So that is a binary variable that takes the value of 1 when rural households use fertilizers and 0 otherwise when they don't use fertilizers. So fertilizers here is, comprises of both organic and inorganic fertilizer. So our second production decision variable is their total investment in fertilizers, and this is captured as the total amount of money in Nigerian naira the spend on fertilizers per acre of cropland cultivated. A third variable is the area of land in acres that they rent in for cultivation. And finally, the last decision variable, which is a proxy for household time allocation for farm work, is income ratio. And that's basically the proportion of income that is from farm work. So moving on to the empirical strategy. So equations 3 to 6 here are model specifications for that, that we used to investigate the effect of the risk perception of farmer-herder conflict on the 4 production decisions we're interested in. So we employ a simultaneous equation model within a conditional mixed process framework to implement this system of equations. And the reason for this is we try to account for farmers' joint decision-making process. At the start of the planting season, farmers have to make a decision on what to plant, area of land to plant on, what productive inputs to use. And this decision tends to be done simultaneously.
In Seattle, it's 7 degrees.
Sorry, this decision tends to be done simultaneously. So to account for that joint decision-making process, and also to make sure to account for possible selection bias in the sample, we implement a simultaneous equation model. Also, we include a vector of other covariates, of other household level and farm level covariates in model specification. So table 2 here presents definition and summary statistics of the key variables in the analysis. So a third of the households in a sample use fertilizers, and on average spend about 13,910 naira on fertilizers per acre of cropland cultivated. In our study, houses in our study renting an average of 0.19 acre of land for cultivation. So our risk perception index variable has a mean of 4.09 with a minimum of 0 and a maximum of 5.67. For other control variables, you see that on average, a household head in a sample is aged about 49 years with over 8 years of education and about 27 years of farming experience. a quarter of the households in our sample are female-headed. So moving on to our findings. Table 3 here presents the result estimates for the effect of the risk perception of farm-herder conflict on rural households production.
5 minutes remaining, Amaka.
Okay, so we see here that a one unit increase in the risk perception of conflict reduces rural households' likelihood of using fertilizers by 8.3%, as well as reduces the investment in fertilizers by 1,734 naira per acre of cropland. On the other hand, on the flip side, we find a positive association with their time allocation for farm work, meaning the more they perceive the risk perception of conflict, the more time they put into farm work. Also, we see that female-headed households are 23.4% less likely to use fertilizers and spend about 5,237 naira less on fertilizers per acre of cropland compared to male-headed households. So table 4 here presents our other analysis on the effect of risk perception of conflict groups on production decisions. And we see that households that have that are at risk averse or in the risk averse group are 47% less likely to use fertilizers. They spend about 10,061 naira less on fertilizers per acre of cropland and use about 0.21 acres of land, renting about 0.21 acres of land less than risk-taking households. And really what this suggests is that the more risk-averse a rural household is, the higher the negative influence of the risk perception of farm-herder conflict on their production decisions. So we get the same results too for gender of household for female-headed households. They are less likely to use fertilizers as well as spend less on fertilizers compared to male-headed households. So we conduct robustness checks and with using logic, target, and fractional regression models, and we find similar results to our main findings. Also, we carry out additional analysis using objective measures of farmer-herder conflict, and our results show no statistically significant effect of the long-term exposure of farmer-herder conflict, as well as the number of the incidences of conflict in their community in the past year on households' production decisions. And what this highlights is that it's not necessarily the actual incidents, or frequency of this conflict that impact rural households, but what could be more important is how they perceive the risk. So they don't have to experience it personally to react negatively to it. So in conclusion, the study provides empirical evidence of the effect of the risk perception of farmer-herder conflict. We see a negative association with the use of fertilizers and investment in fertilizers, and on the flip side, a positive association with households' time allocation for farm work. So this findings suggest that the detrimental psychological effect of farm-herder conflict has enormous implications for rural livelihoods because of its effect on reduced investments in agricultural production. These findings we recommend strategies targeted at improving rural farmers' efficiency and production and productivity need to increase their perceptions of physical security, certainty, and safety. Also, we think that to ensure sustainable farm food systems. So climate change really is not something that's stopping anytime soon, unfortunately. So to ensure sustainable food systems, there's a need to develop, a policy framework for more sustainable herding practices. For example, cattle ranching. Thank you.
Thank you, Amaka. That was excellent. You kept it to the time, and it's a very very interesting presentation. And I like the fact that you have looked at a very important kind of risk, but something that's rather less looked into. So that's, I like the presentation in that sense. I have a couple of questions. One is, do you think the kind of measures you used, the kind of inputs you inputted into the index actually measures conflict? The kind of conflict, the farmer pastoralist conflict, isn't that a more general kind of risk perception measure. I mean, couldn't we apply that to climate risk, production risk, market risk, that kind of stuff? So would you like to comment on that? And I think in my view, it would be more interesting to zoom into specific kind of measures that are directly correlated, could be directly correlated with conflict, farmer pastoralist conflict kind of risk. That's one issue that I'd like you to comment on. Another one is a comment. I mean, risk perception, risk loving, risk neutral. Those kind of measures are actually associated directly with risk preferences and not necessarily risk perceptions. So I'd be careful in using those terminologies in association with risk perception, although your categorization is fine. And I would also suggest that instead of putting them into an index, it would be interesting to disentangle the different measures and use the different measures separately in your regressions. But that I suspect is one of the reasons you didn't find a lot of, as much significance as you would have liked in the regressions. I have also the same set of comments on your dependent variables. So fertilizer use, income ratio, except for land rental, are they really, it can go both ways. For example, when it comes to fertilizer use, does it really directly associate with risk of conflict? Don't people want to use, productivity enhancing, short-term productivity enhancing external inputs when there is conflict instead of doing long-term investments like soil conservation? So these are the three comments. Mark has two sets of comments. So maybe you could look at Mark's comments as well and answer them in one go.
Okay. Can I respond to some of the? I hope I remember though. Can I respond to some of the questions you just posed? Can I respond to the questions now?
Yes, please.
Perfect. So you asked about if I remember clearly, your first question was on how we measure risk perception.
Yes, if your measure of risk perception are not more general than you would have liked, do they really measure conflict? Yeah.
Well, so I think they do really, because the how we came up with the risk concerns we use was that we used, as you mentioned, you said, general concerns, right? Conflict concerns. But then when this question was posed to respondents, they were asked to think about it from the context of conflicts occurring in the past. So it was a recall, from
right.
that occurred or conflict they were aware of in the past agricultural season. And I mentioned we carried out a pilot study in the survey area, and this was done to make sure to improve the validity of the instrument. So we got their feedback, and we used it to sort of update or to further improve our measures of risk perception, or the items we use to capture concerns by households, as relates to prior occurring conflicts, before the agricultural season. So I believe, and then of course we try to use as objective as possible a measure to come up with an index. We used a modification of the risk ranking method that's been used in the literature. I know that there always be criticisms on the best way to capture risk perception, but that's the best we could do, I guess. Your second question, I think, was on what was that?
So on the dependent variables, are they really
beautiful?
Don't they go both ways? Yeah,
I know. So so yes, we also got that criticism when we submitted it to be published. So income ratio is not a really wonderful measure for time use, but that's the best we could do with the data. But I would argue that fertilizer use, the decision to use fertilizers again, and also the investment using the amount of investment in fertilizers is an appropriate dependent variable. Because even from literature on effect of armed conflict, we find that with uncertainty when there's a presence of armed actors in their communities, farmers tend to move from more productive inputs to less productive decisions. So they tend to move from cultivation of food crops to cultivation of cash crop, perennial crops to more annual and also to annual production. They tend to sell off their livestock portfolios. They tend to use less productive inputs for cultivation, probably because of the fear of or uncertainty associated with this conflict.
Yeah. Okay, so Mark has a couple of questions he has posted on the chat, so you could respond to that.
Misperception. So
yeah, we have 3 minutes,
Mark.
So if you could do that in 3 minutes, yeah.
Thank you very much, Mark, for that. So really, so there are differences. I didn't provide that. I didn't show that in the slide, but there's we do a sort of disaggregation between the risk perceptions, the risk assessment index for each of those concerns between female-headed households and female farmers and male farmers, and there are differences. So men tend to be more to have a higher risk perception related to, say, use of land and destruction of property. Well, women tend to have a higher risk aversion or risk perception of this conflict when it comes to lack of food or shortage of food in the household. So I guess it depends on that. Like they probably look at the risk of this conflict from different perspectives. Men more from property holding or access to productive input, and women more from the angle of care of body for their households, food security for their households. And your second question was on, have you examined the effects of gender risk perception interactions? No, we did not do that. And in hindsight, that would have been a really good, would have added a really good dimension to the analysis, but we didn't do that for this paper.
Thank you very much, Amaka. So we've really kept within that time, and everybody join me in congratulating Amaka on an excellent presentation and discussion.
Thank you very much, Mintewab. Always happy to present my work to the EFD network.
Okay, so with that, we move on to the next presentation. So our next presenter, let's welcome Raavi, our next presenter. Her talk is on optimal emission pricing in LIMCs, accounting for household emissions from traditional cooking. So to save time, if everybody could type your questions as Mark did while Raavi is presenting, that would be excellent. Thank you.
Yeah, thanks so much, Minta and Amaka, for being there. Thanks to EFD for having me in the webinar series. So I'm very happy to present this paper. Sorry, I just need to get the slideshow running. Great, there we go. So I'm very happy to present an overview of this paper that we've been working on in EFD for about 3 years. So we have some of the center heads involved in the studies. We have Som from Delhi, Jan from Germany, and Thomas is there as well from Sweden. And the initial idea that they had was basically, can we apply a uniform global carbon price also in the context of low and middle income countries to mitigate climate change? And the reason we can't always do that is because there are very specific externalities and market failures in developing countries that don't usually get accounted for in these cost-benefit calculations. And so in this paper, we're looking at the very particular case of people using biomass for cooking and how a carbon price might interact with that and what might be the costs and benefits of having a carbon price in place. So traditionally, it's been said by economists that you need a uniform global carbon price for efficient emission abatement, and you need a fairly high carbon price of around $50 per ton of CO2 at least. But at the same time, we know from many studies that high fuel taxes in developing countries reduce consumer welfare. So, for example, there might be energy poverty. People could simply consume less energy. There might, of course, be an increase in demand for solid fuels that are highly polluting in nature. And so one study by the World Bank estimates that these costs from indoor air pollution are around 4% of GDP on average across the developing world. So on the right, you see this graphic, which is a very typical kitchen in South Asia. So this is from India, but I'm sort of extrapolating also for South Asian countries. So the woman here is cooking on something called a chula, which is emitting black carbon and carbon monoxide continuously. And because this is a very inefficient cooking process, it takes them very long to actually prepare a meal. So women and children might be exposed to these fumes for up to 12 hours a day in rural areas. And most of them are not aware of the negative effects because it's also concentrated among less educated areas. The other side effect is that women then don't have time to work in the labor market because they're actually collecting fuels. So you see this other graphic, which I pulled out from Uganda. On the other hand, people argue that a carbon price can help you generate some benefits in terms of, first of all, collecting revenues. So a source of revenue is extremely important in developing countries because governments are, fiscally constrained. And so people argue that you can just invest those revenues in other developmental goals, and that can also help you achieve some developmental benefits. So what we're trying to do is do a cost-benefit analysis and see whether it makes sense to have a carbon price in place. So specifically, we're going to look at a sample of 6 developing countries because that's essentially what we had data for, and I'll explain that in a minute. But we're going to contextualize this carbon price in a very specific context of people cooking with biomass. So what we're essentially comparing is that there's a global benefit from reducing CO2 emissions, where everybody benefits from reduced emissions. But at the same time, there's a very localized health externality because only people consuming those biomass sources and people living in the neighboring regions are suffering from increased air pollution. And the way we're going to do it is that we want to understand that basically if you introduce a carbon price on a fossil fuel, how much increase in biomass might occur for cooking because of that increase in the fossil fuels price. So to take a simple example, if we just consider 2 fuels, for example, cooking gas and firewood, which is the case of India, if you increase the price of cooking gas by 1% based on a carbon price, what would be the change in firewood demand due to that increase in the price? And to do that, we want to estimate elasticities between this biomass and fossil fuels. So that's essentially what we're doing in a very integrated framework. So we're applying a consumer demand system, and we will account for things like zero expenditures and all the major problems that are occurring in this literature. And what we essentially wanted to do was to have a uniform method that could be applied to many countries so that it basically you can get a data set from a developing country and you can apply this method, and you will have a robust way of comparing results across countries. So we try to do this for 6 countries. And then we will comment on the costs and benefits of the price. So I'll briefly go over the methodology. Essentially, we're using the exact affine stone index demand system. This is the latest in the field. And what you essentially do is you look at the budget share for a particular cooking fuel. So in our case, we look at fuels such as electricity, cooking gas, kerosene, charcoal, and firewood across countries. And we try to relate that to the prices of each of these fuels and to the household income. So of course, it's possible to include more control variables in this regression, like household size, dummies for rural urban areas, etc. But because we have a nonlinear because we have a nonlinear estimation, it's hard to include many of these controls. So we can talk about that in the Q&A. But in the most simple specification we have, we just want to see how demand for the fuel changes with respect to the price of each of these fuels. So we estimate these compensated elasticities, and it's very important to look at the compensated demand effects because essentially the argument we're making is that if we introduce a carbon price in a developing country, people are going to face a welfare loss. From any fuel price increase, there will be a welfare loss. And so we want to make sure that people are able to achieve the old utility levels before the price increase. So we have to compensate them with just enough money that they need to attain their old utility levels in the strict economic sense. So essentially, when we measure the compensated elasticity, we already get this compensation embedded into our estimation. So what it means for policy is that we are assuming there are going to be international transfers that are just enough to compensate people for the carbon price increase. So basically, there won't be any welfare loss generated. And now we just want to see the impacts on demand. If there are any clarificatory questions about the model, please feel free to ask. So essentially, we went on this very long drive with some of my co-authors to try and find good data sets for this study because we wanted to cover as many countries in LMICs as possible. But what we came up with was a handful of six countries. And the main criteria was that essentially we want to look at this substitution between a fossil-based fuel and a solid fuel for cooking purposes, because we want to be able to capture the substitution correctly in our demand system. And so we've selected these countries if at least 10% of the population is consuming a fossil-based fuel and or a particular solid fuel for cooking. So I have the detailed descriptives in the paper. I don't have them at the moment, but our sample basically spans 3 different continents. So we have Honduras from Central America, then we have Ghana and Kenya from Sub-Saharan Africa, and then we have India, Cambodia, and Myanmar from the Asian region. And those are the 5 different fuels we're talking about. So for India, the data is slightly outdated, but this is the latest survey that was available. And what we want to make sure of is that the prices are not being influenced by household decisions. So the way we do that is we take the household price that's reported for a cooking fuel, and then we create averages at the district level and by rural and urban area. So we will assume that the household price is basically an average at the district level. And so there's an underlying assumption that households are not influencing the prices at the district level. That's very important to identify the elasticity correctly. So we do find significant heterogeneity in prices, and that's our one sort of way of making sure that prices are not endogenous in the model. So now just turning to some of the results. This chart is basically trying to summarize the interactions between the fossil-based fuels and the solid fuels. So in the rows, you'll see the 3 fossil-based fuels here: electricity, LPG, and kerosene. And on the right-hand side, you have firewood and charcoal. And if you look at the symbols that are to the right of this black solid line, it means that when the price of the fossil fuel increases, there's an increase in the demand for a solid fuel. So in many cases, you see that there's an increase in demand for firewood and charcoal. And along this horizontal line, it's basically for the same country. So in some countries, people are using both firewood and charcoal for cooking. And so we see what is the interaction going on between these 2 fuels. Now, it was a bit of a puzzle, but in some cases, in some countries, the demand for firewood is actually falling when there's an increase in the price of a fossil-based fuel. You'll see that the demand for charcoal never falls, but demand for firewood is falling. And in most cases, this is actually what we've observed is a substitution between charcoal and firewood. So in some cases, you'll see that the demand for charcoal increases, but the demand for firewood falls when there's an increase in the fossil fuel price. So for example, in rural Myanmar, this is happening, and in many other cases as well. So the full details are in the paper. And to some extent, we are still investigating this, but what's interesting is that, we observe this in many different contexts, applying the same method to different data sets. So it gives some assurance that there must be some deeper pattern going on that we are still investigating. So just looking at some of the detailed results, we clearly find a pattern that there is an increase in the demand for solid fuels when you tax LPG or electricity or kerosene. So we observe this in 3 different contexts in Ghana, Honduras, India, and there are other cases also in the paper. So for rural Honduras, the elasticity is actually very large. So it means that if the price of LPG goes up by 1%, the demand for firewood is increasing by 3.6% in rural Honduras. This is for the average household. So for the other cases, the elasticities are still reasonable, but for Honduras, it's a very large increase. And this suggests that we will find large health costs of consuming this extra biomass. So there are some questions in the chat, I think. You could just intervene, I don't mind. Okay. So there's another thing going on. So I was mentioning this substitution within solid fuels. So I just want to give a little bit of evidence of that. So for example, in urban Kenya, we see that if you increase the price of LPG by 1%, the demand for charcoal is going up, but the demand for firewood falls. Similarly, we observe this in urban Myanmar when you raise the price of electricity. So there is some indication that people are able to cook their meals by substituting fuels that are either not available in those regions, because this is mostly urban areas. So it could be that firewood becomes more scarce and hence less, more costly. It also could be that there's a substitution in terms of the energy content. So charcoal is less energy intensive than firewood. So you actually need lower amount of charcoal to prepare a given meal than firewood. And so on average, it could actually be cheaper for a household to just consume a little bit more charcoal than a lot more firewood. So we are still investigating some of these mechanisms. And we're trying to characterize exactly what's going on, but we don't have exact data on exactly on the meals they're cooking and so on. So this is a very kind of macro study. Now I'd like to move past the elasticities and show you the cost-benefit analysis we are still conducting. And we've done many iterations of this, but there are a couple of results that have been pretty much stable and uniform across all the iterations we've done in the last couple of years. So the first question is, what is the climate benefit from taxing these fossil fuels? So if you have a carbon price in place, there will be some emissions reduction because fossil fuel consumption will go down. And so we're trying to evaluate those benefits. And the key parameter we use is the social cost of carbon. So, and this is basically the value judgment involved in this study. And I will talk about the parameters we're using precisely. But essentially, we're able to use these elasticities to calculate exactly what the emissions reduction will be. And how do we evaluate those emissions reductions? We apply the social cost of carbon. So on the one hand, you have this emissions reduction. But on the other hand, if you have an increase in solid fuel use, you'll also have increased deforestation. So to some extent, we've tried to measure the increase in emissions that will happen from excess solid fuel consumption. Now, this is actually rather uncertain because we don't have so much data on it. We're relying on a study by Rob Bayliss and others, which provides detailed estimates of shares of non-renewable biomass and so on. So we're relying on those things, but the main argument is that there are some climate benefits from reducing fossil fuel consumptions. On the flip side, we have local health costs, which I talked about. And so the exercise here is, can we estimate the increase in premature mortality that will happen from more indoor air pollution? So there are multiple steps involved in this study. And essentially what we need to do is we need to understand that if there's a 1% increase in the price of a cooking fuel, what is going to be the increase in indoor air pollution within the home? And how does that increased pollution relate to the mortality risk that a person experiences? So here we're relying a lot on the public health
5
literature.
minutes remaining.
Thank you. And studies from epidemiology that give us a lot of these models and parameter estimates that we're using. So now we'll be drawing a lot on other studies that have already been published. And so based on these costs and benefits, we want to understand whether it's economically cost effective to have a carbon price and in which country it should be the case. So in the interest of time, I will quickly go through some of the steps. So as I mentioned, we want to basically estimate this excess mortality from increased biomass consumption. And to evaluate this excess mortality, we're going to apply the value of statistical life. And our estimates of VSL are quite conservative relative to the literature. And despite these low estimates of VSL, for example, compared to estimates from the US, we still find very large health costs of a carbon price in pretty much all the contexts that we're studying. So just before I show you those results, I just want to show you the difference in pollution levels that we've estimated. And the way we've done this is we've relied on a study by Matt Schuppler and others that was published in the Lancet, I believe. So there they've actually estimated what is the indoor pollutant concentration from using different types of cook stoves. So based on that information, we've been able to estimate the pollution levels that are currently prevailing in homes in some of these countries. So you can see that in the column over here. And based on the price increase for a particular fuel, we can calculate the resulting pollution levels after the price increases. So in the final column on the right, you see the change in pollution concentration. This is PM 2.5 in micrograms per cubic meter. So except for the case of urban Honduras, which I'll talk about in a minute, we see an increase in pollutant concentration in all the cases. So even where people are reducing firewood consumption and substituting it with charcoal, we still find a moderate increase in pollution concentrations within the home. And now I'd like to present the main results. So we have multiple different estimates that we've done, but what I'd like to focus on are just those two things that I talked about at the beginning, which are what are the climate benefits from imposing a carbon price, and what are the local health costs of increased taxes on fossil fuels. So in this particular column, you see the climate benefits. These are in millions of US dollars. So you actually see that the benefits are rather small in terms of, when we compare to the health costs. In India, it's actually quite large. So this is in aggregate terms. This is not yet in per capita terms. We've also done this in per capita terms, and we actually find that per capita benefits in India are much lower than other countries. So this is actually this population effect that's masking the per capita benefits. So we see that, the order of magnitude is, say, $265 million from imposing just a 1% price increase for LPG. Now, a 1% price increase for LPG only corresponds to a carbon price of, say, $3 to $5 per ton of CO2. It's a very low carbon price. And so there are some substantial benefits. But now, if we look at the health costs over here, we see that the health costs are enormous. So here for India, we find $950 million, so close to $1 billion in just health costs of having a small increase in LPG prices. And that's simply because the volumes are huge. So when we look at the final column, we're subtracting the cost subtracting the benefits from the costs. And we see that in most cases, there is a net cost of imposing a carbon price in most of these countries. Simply because the health costs are enormous. And at the moment, we don't have a mechanism that will ensure that these health costs are somehow compensated for. So remember that this is happening even after there are international transfers, because we're using the compensated elasticity, as I mentioned. Now, one puzzling issue here is that of Kenya. So you see here that the benefits actually exceed the costs. But I mentioned that we're also calculating the increase in emissions from consuming more wood fuels. Thank you. So we actually see that there's a negative, so there's actually a climate benefit in Kenya. But the takeaway is that the health cost is still positive. So we still need to account for these different types of costs and benefits. So there are a number of limitations of the study, like we use these nonlinear regressions. It's a huge average and approximation that we're doing. And we're also making some assumptions about, efficiency of cook stoves and so on. But just to conclude, I would say that we clearly find evidence that the local health costs are exceeding the global benefits of a carbon price. And so it has some implications for the kind of policies that are needed. So the first clear implication is that we do need potentially need some subsidies for clean cooking fuels. And that could also be that we subsidize electricity consumption and we derive electricity from renewable energy. But also it has some implication for the entire literature on providing improved cook stoves and basically making sure that we're able to provide clean cooking technologies. So I think that's the main conclusion that's emerging from the study. So I'd like to thank you for your time, and I'm looking forward to your questions. Thank you.
Thank you very much, Raavi. So this was an excellent presentation, and you have again kept within the time. I have two short comments, and then Gerald and Daniel have posted their comments, and you can react to that. So one comment I have is on, to me, the health cost of carbon pricing seems very exaggerated compared to the climate benefits. And I'm just guessing this could be because you haven't really taken into account the possibility of people shifting towards more cleaner energy when there is a price increase. You haven't taken that into account in your cost-benefit analysis, have you? So that's one question. Another is with the puzzling price demand shifts in demand between clean and dirty energy consumption. And I'm just guessing this probably has got to do with how you have aggregated prices, because you've done district level aggregation, right? And that
Yes.
that implies aggregating rural and urban prices, which tend to be very, very different. So have you thought of a lower level of aggregation instead of a district level aggregation? So these are my 2 comments.
Okay, thanks. Maybe I'll just respond to your comments before going to the ones in the chat. So, so actually we did segregate by rural and urban. But it's true that for entire rural area, it's sort of together. We have district level prices, but that's true. So I didn't quite understand what you meant between clean and dirty energy. Were you referring to the shift between firewood and charcoal, or between fossil fuels and biomass? That could.
Where you had I think it was the I forgot which one of them was, but there was this this slide where you had puzzling results between the substitution. I thought it was clean
Yeah, I think
energy.
Yeah, we're still investigating that. That's a good point. But it's true that what we haven't accounted for are renewable energy sources. In some parts of East Africa, people are switching to renewable energy-based cooking solutions, and we didn't have any data on that. We've not accounted for that. So somehow in our analysis, we're saying that we need to impose a carbon price on fossil fuels, and yet the only possibility is to shift from biomass to fossil fuels. So there is no way for people to actually substitute out of either of these sources, and eventually we need people to shift out of both. So I think that is a key limitation of this analysis, which is based on the data set we had. I think I understand. So I think the health cost might be coming out very large because you see, I had this table where I showed we actually estimated the excess mortality here in delta here. So to each of these numbers, we apply the VSL. We just multiply these. And because the VSL is something like $200,000 per to avoid one particular death. And so when we apply that, we get large numbers in millions of dollars. So that's one thing, but again, that's a value judgment. So we're still stuck with that. I think I'll quickly have a look at the questions in the chat so we can keep to time.
Thank you.
So actually, we've not accounted for taxes on the transport and industry sectors at all. It's true that there would be some input supply linkages. So I'm just responding to Daniel's question. But so we are assuming, in a sense, that there's actually no link between demand for cooking fuels and demand for transport fuels. That could be a bad assumption, but essentially we're assuming that because we don't expect any effect of increases in transport prices on demand for cooking fuels in particular. So we selected our sample to make sure that people who are using these fuels for cooking, and we only select those fuels that are being used for cooking. So we don't have different carbon prices for different sectors because we're assuming that a country will only be able to feasibly implement one carbon price. So we also don't have different carbon prices for rural and urban areas. We're just assuming one uniform carbon price for each country. So again, this is a very approximate kind of study. So we don't have any data on how much food is being cooked and the type of food being cooked. So we're not able to account for that. I'm just looking at Mark's comment now. Yeah, we haven't looked at other climate forcing pollutants. I know that in the Baylis paper, they have a few other things. Black carbon, yeah, we haven't looked at black carbon emissions. Actually, even the estimates of methane seem to be very uncertain because here we've applied a social cost of methane of $4,000 per ton of methane, and the CO2 price is $185 per ton of CO2. So, I mean, there's also a subjective issue there that people may not agree with that. So we don't disaggregate between rich and poor in urban areas because it was difficult anyway to actually run a demand system. So we should have done it by income groups, but we couldn't do that. I think I've answered most of the questions.
Thank you very much, Raavi. Is there any other question from the floor? I guess there isn't. Alejandro has posted a link to those who are interested in exploring more of Winnie's work. And please join me in thanking these two excellent presenters for imparting their knowledge on their work. And thank you very much for the host of the series for giving us the opportunity to host this particular episode.
Thank you so much.
Thank you.
Thank you. Bye. Bye, everyone.